Let's talk about control structures in R. Control structures are essential for conditional execution of code, taking us a step beyond merely using functions. The if statement evaluates a condition inside the parentheses. If it's true, the code inside the curly braces is run. For example, if my score is greater than or equal to 60, R would print you passed. At this point, it's useful to talk about the comparison operators. For these four, it's quite straightforward. For the not equal to, use the exclamation mark for the not part followed by an equal sign. And the most important thing to remember is to use double equals for evaluating whether two objects are equal. The single equal sign is for value assignment. Never use the single equal sign for comparisons. Relatedly, there's the logical operators. Use double AND signs to evaluate two conditions. For example, true and false would result in false. Double vertical bars stand for OR. For example, true or false results in true. And here again, the exclamation mark denotes not, inverting the logical value that comes after it. For example, the is.na function checks whether my score is NA, a missing value. So this returns false, and not false is true. The single AND and single OR operators are for element-wise evaluation between two logical vectors. The result will be a logical vector of the same length. You can pair the if statement with an else statement. In this example, two conditions are evaluated with the AND operator. If my score is greater than or equal to 70 and less than 80, it'd be true and true for the value of 79. So R would print your grade is B. Else, meaning if my score is any other value, print your grade is not B. For multiple conditions, you can insert multiple else-if statements. Here, I have several grade thresholds. First, check if my score is greater than or equal to 90, which is letter grade A. If the score doesn't satisfy the first condition, further check if it satisfies the second condition in this else-if statement. If it doesn't, go to the next else-if, and so on, ending with a final else statement to handle the rest of the possible scenarios. Use loops to repeat tasks. The for loop iterates through a sequence of elements and executes the same code for each element. In the parentheses, we set a loop variable called I, or any other valid variable name, in a vector. I will hold the value of the first element from the vector in the first iteration, second element in the second iteration, and so on. Recall that variables defined in a function are in the local environment of the function. In contrast, the variable used here in the for loop is in the global environment. After the loop is finished, i's value stays the last element in the vector. The while loops are another looping mechanism where the code is executed as long as a condition remains true. In this example, the variable count starts at 1. 1 is less than 5, so print the first element from test scores. Count is increased by 1 at the end of every iteration. But as long as it's less than or equal to 5, execute the code. It's possible to create infinite loops using either the repeat loop or the while loop where the condition is always true. Infinite loops should have stopping conditions in place to prevent your program from running forever. If by accident you started an infinite loop without stopping conditions, find and press the stop button. Use the break statement to terminate a for, while, or repeat loop. Use the next statement to stop the current iteration and continue on to the next iteration in the loop. Control structures are essential tools in R, directing the flow of your program based on conditions. For deeper understanding, craft small scripts with different conditions and see how R responds. The more you experiment, the more proficient you'll become.